Kinematics is an area of Newtonian physics that explores the physics of motion. It is very mathy and is not without plenty of formulas and equations. But there are four main formulas that I want to dive into this video, the kinematic formulas. When I first started learning about kinematics, I was very confused by these formulas, like where did they come from, and how do I use them? So I hope to show you that these formulas did actually come from somewhere and when to use them, but we must first start with the variables. These formulas have plenty of variables, 5 in fact, so let me introduce them to you. The first one is delta x. It represents displacement, which is kind of like distance, but there is a small change. Displacement is a vector, and distance is a scalar. Also, displacement can be negative, but distance cannot. What this means is that if I said I walked 10 meters and did not tell you where, I would have told you a distance. But if I told you I walked 10 meters east, I would have told you a displacement because I gave you an amount, 10 meters, and a direction, east. And that is what the difference between a vector and a scalar is. One gives you a direction and one does not. It is very important to check if you are working with a vector or a scalar. Now the second and third variables are vi and vf. Or initial velocity and final velocity. Initial velocity is your velocity right when you start, and final velocity is when you finish. They are both basically just speed, except velocity is a vector and speed is a scalar. The fourth variable is t, or time. Technically, when you use t in an equation, it actually means your change in time, or delta t. Also, just so you know, you can't have a negative time. The last, but certainly not least, is a, or acceleration. And acceleration is just how much your velocity changes over time. And it is also a vector. But there is one small caveat to this. Your acceleration cannot change for these formulas to work, which is pretty normal for pretty much any kinematics problem. Finally, now for the formulas that you've all been waiting for. The first one is... You thought I was just going to tell them to you, right? No, of course not. We got to derive these first. The first one is fairly easy to derive. You just take the definition of acceleration, delta v, divided by t, and then rearrange it to vf equals vi plus at, or in English, your final velocity is equal to your initial velocity plus your acceleration times time. And that is the first kinematic formula. The second kinematic formula isn't as straightforward, but we can find it pretty easily. It starts with a velocity versus time graph, and we all know that the area under a graph is your displacement, since the units of area under a graph are both units times each other. In this case, velocity times time is equal to displacement. And we can tell that the area under this graph is a triangle and a rectangle. The area of this triangle is 1/2 v final minus v initial times time, and the area of this rectangle is vi times t, and when we add these together we get delta x equals t times vi plus vf divided by 2. Or in English, your displacement is equal to your time times your average velocity. Now for the third kinematic formula, we just look at our last graph, and instead of writing down v final minus v initial, we instead use our first kinematic formula to find that v final minus v initial is equal to a times t. And we use this to get that delta x equals vi times t plus 1/2 a times t squared. And finally, now for the fourth kinematic formula. We just plug in the time from the first formula into the second kinematic formula, then we simplify and rearrange, and we get v final squared equals v initial squared plus 2a times delta x. Now you may have a very important question. Why did we just do all those strange substitutions in algebra that look like they came out of nowhere to get these formulas that at the moment doesn't seem that very useful? This isn't that hard to answer, and I hope that you will find the answer to be very enlightening. The first formula isn't that weird. We just rearrange the formula for acceleration to solve for final velocity. The second formula is also something that's pretty normal. It's not that weird of a thing to need to find the displacement from under a velocity versus time graph. But the third and fourth seem pretty mysterious and need explaining. What we were trying to do is get one variable into the expression and one out. You might have noticed that each formula is excluding one of the variables, except for initial velocity, because 1, most problems use it to solve for something else, and 2, most of the time we aren't solving for vi, but if you want the formula, just plug in the first formula into the third. So when we were trying to find the third and fourth formulas, in the third we were getting rid of the final velocity, and in the fourth we were getting rid of time. And we do this because in kinematics problems, they want you to solve for one variable and you are given 3. And to find what formula to use, just use the formula that uses all the variables you were given. Well, technically speaking, we are normally not given an acceleration, unless we're talking about gravity, of course. Instead, we are given a force F and an object's mass, m. But it doesn't make it that much more complicated. We just, instead of writing down a, we write down F over m from Newton's second law, F equals ma. I'm not going to leave any examples in this video, but I will leave a link in the description to a practice sheet so you can check your understanding, because I really do think that your understanding does not come till you've actually practiced what you've learned, even if it's just doing some algebra problems. But anyway, I hope you've enjoyed finding these formulas, which seem to have come out of nowhere, actually don't. Thanks for watching.